Hi, my name is Joshua Miller. My wife, Shannon Miller, is the director for CC Rainbow Monday in California. And we're going to go over our next science experiment, which is number 88, Tug of War. Now, if you'll go back and review number 86, the Where Did It Go, you'll kind of remember some of the things we talked about covalent bonds and hydrostatic bonds. But as a quick, super fast review, if we have Minnie Mouse here, the water molecule has oxygen and hydrogen. So the hydrogens are the smaller ones. It actually looks just like a Mickey Mouse, head and ears. So we've got the oxygen is the bigger one, and the hydrogens are the smaller ones. Now there's a weak bond between the hydrogen and other oxygens, but a strong bond between the oxygen and the hydrogen. Now, why that's important and why that's significant is it makes it so that water has what is called surface tension. Water sticks to itself. If you've ever gone and taken a nickel and taken an eyedropper and dropped droplets of water on it, you can see that the water will form a bubble. It's actually sticking to itself, surface tension. It's a very weak bond. That's the hydrostatic bond. There's space in between each of the molecules because they have the strong bonds and the small bonds. There's actually space in between different molecules. Kind of like, I know these are different sizes, but we would have a hydrogen and an oxygen attached over here, but then this one has hydrogen and oxygen, and maybe you'd have another one over here, maybe another one over here. So there's actually space inside of, in between each of the different water molecules. Water is actually known to be the best absorber of any other liquid substance. It can absorb lots of things. I don't know if you've ever gone and put salt in water. The salt will absorb in the water, or baking soda, or you can mix lots of different things into it, and they'll absorb into it. So what this experiment is showing is we're going to do that with some rubbing alcohol. So I have some 91% isopropyl alcohol here. I've already gone and made my water with some blue food coloring. We made a dark sample of it so that we can see it. I'll set that aside. I've got a piece of aluminum foil right here that we're going to put on here. Now, in the book it says to use an eyedropper. Now, you don't technically have to use an eyedropper. You can use a pipette. An eyedropper is pretty much the same as a pipette. It's just it's made of glass. It's usually shorter, and it has a little rubber head, whereas this is all just plastic. It's just for grabbing some of the stuff and dribbling it on here. Now what you want to do is you want to make this as thin as possible. So we're going to put this on here, hopefully no bubbles. I'm going to put this on here, try and get it as thin as we can. The thinner that it is, the better. So we'll see if we can kind of spread it out a little bit. If your table's really nice and flat and level, it'll work better as well. My table's a little off kilter right now. As you can see, the water's flowing in one direction. So then what we're going to do is we're going to take some of our rubbing alcohol, and I forgot to open it. There we go. And we're going to get just a little bit of our rubbing alcohol. And what we're going to do is we're going to put it in the center. Now, what's going to happen once it gets into the center, watch carefully, is we're going to put it in the middle, and it's going to push away all of the water. Now, what's going to happen is the water's going to slowly absorb it, and you'll kind of see the water kind of moving and bubbling a little bit. It kind of looks like, I don't know if you can see when you're looking real close, it looks like it's moving. I'm not touching the table. There's not an earthquake going on here, at least not the one that we're aware of. But the water is and the rubbing alcohol are kind of bumping against each other. What's happening is the water is trying to stick to itself, so it has the surface tension going on, but then at the same time the rubbing alcohol is trying to go, and it's trying to go into the water. It's trying to be absorbed by the water. So that movement that we see, eventually, if we waited long enough, all of this would be one big bubble again. And it works, like I said, a little bit better if you're on a flat surface. We'll try and do it right here, maybe a drop here. Put it, there we go. Whoops, I guess we kind of mixed that really fast. But you kind of see the coloration difference. You see how it's kind of like moving around? It's mixing it together because the rubbing alcohol is being mixed into, and it's being absorbed into the water. You can really see it really good right there.
Don't shadow.
Now when the two liquids are completely mixed together as much as they can be, all of that movement, the water movement, will stop. There you go. Kind of see it right there. Getting absorbed in there. It's going, see how it's getting smaller, 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 smaller. We'll do it another time over here. Another drop. It's trying, the water's trying to absorb it. And that's because of the space between the molecules of water.